On today's episode, something wild is happening right above our heads. A 50-year-old Russian spacecraft is falling back to Earth. Alongside that, a new rocket-powered catapult is attempting to fling payloads into space. And over in China, a spacecraft eerily similar to SpaceX's Starship has officially entered construction. But let's start with that ancient Russian probe which launched way back in 1972. The Soviet Union had sent it on a mission to Venus, a small but insanely dense metal capsule filled with scientific instruments. The plan was bold. It would dive through the thick, acidic clouds of Venus and land on the surface, where it would try to survive for as long as possible in one of the most hellish environments imaginable. But things didn't go as expected. The mission failed, and now, over 50 years later, that same probe is finally coming home. Here's something wild. A recent telescope video filmed in May 2025 shows a tiny dot streaking across the sky. It's not a shooting star. It's not a satellite or even an asteroid. That's the old Soviet Venus probe from 1972, still up there after all these years. But it's not going to stay up there for long. This weekend it's making its final descent back to Earth. What went wrong? Back in '72, a malfunction in the Soviet rocket booster left the probe stranded in an unstable orbit roughly 10,000 kilometers, or 6,000 miles, above the Earth. And ever since it's been slowly falling. Officially, the spacecraft is known as Cosmos 482, but it was originally part of the Soviet Venera program, an effort to explore Venus throughout the 1960s, 70s, and 80s. After the rocket failed, the Soviets renamed the probe from Venera to Cosmos, trying to play it off like it was just a regular Earth satellite, not a failed interplanetary mission. They did this a lot back then. If a mission didn't go well, they'd just give it a generic name and pretend like everything was fine. But Cosmos 482 was launched at the exact same time as Venera 8, which was its twin. Venera 8 actually made it to Venus, sent back data from the surface, and lasted about an hour before it finally melted down. Meanwhile, Cosmos 482 was left floating around our planet for the next half-century. Now here's the twist. Space junk like satellites and rocket parts falls down from orbit all the time. We don't usually pay attention. Maybe a few pieces survive re-entry and land in a random field. But this one? It's different. Cosmos 482 isn't just any piece of metal. It was designed to survive the brutal environment of Venus. That means it's built like a tank. We're talking about a thick outer shell of solid steel and a second inner sphere made of titanium to protect its delicate instruments. So when this thing hits Earth's atmosphere, it's not going to disintegrate like normal debris. It won't burn up, it won't shatter. It's going to punch straight through like a 500-kilogram, or 1,000-pound, cannonball. And it'll be coming in hot, traveling at more than 150 miles per hour, or about 250 kilometers per hour. And the scariest part? We have no idea where it's going to land. None. So, all we know right now is that it could land anywhere between 52 degrees north and 52 degrees south latitude. That covers most of the world, from the tip of South America all the way up to northern Russia. So yeah, that includes my house, your house, and just about every major city on the planet. Should we panic? Honestly, no. Most of Earth's surface is covered by oceans, so the most probable scenario is that it splashes down somewhere remote. And even if it lands on land, the odds of it hitting someone are extremely low. There's still a lot of open space out there, farmland, forests, deserts. The real danger would be if this thing just happened to crash straight into a densely populated area. A high-rise apartment, for example. But again, that's a pretty low probability. The original probe did include a parachute designed to slow its descent through the thick Venusian atmosphere. The question is, what shape is that parachute in right now? Some astronomers think it may have already deployed in space, dragging behind the probe and doing absolutely nothing. If that's the case, it'll probably burn up during re-entry and won't affect the fall at all. If the parachute is still packed inside the probe, then it becomes a bit more complicated. There's no way to know whether the automated system to deploy it still functions after all these years. And even if it does, it was programmed for the unique conditions on Venus, not Earth. Venus has a much denser atmosphere than ours, about 90 times thicker. So the parachute was built smaller, knowing it would catch more resistance on Venus. If it somehow deploys here on Earth, it probably won't catch enough air to matter. Maybe it slows things down slightly, but nowhere near enough to make the impact gentle. The bottom line is, parachute or no parachute, this thing is coming down fast and hard. What makes it trickier is that scientists can't accurately predict where it'll land until it starts its final descent. Once that begins, we'll only have about 20 minutes of advanced notice. That's not a lot of time to warn anyone or move out of the way. So far, the best prediction we've got is that re-entry will happen on May 10th. That could change slightly depending on atmospheric drag and orbital shifts, but it's the most current window we have. So if you're the kind of person who likes to skywatch, maybe keep an eye on the horizon this weekend. If you see a glowing fireball streaking across the sky, don't panic, but definitely take a moment to appreciate the sight. It's not every day a 50-year-old Venus probe comes crashing down from space. Also, have you ever had that gut-twisting moment where you realize your private data, like your name, email, and even your home address, is just floating out there on the internet? Some random company you've never heard of might be selling it off to the highest bidder. You could spend hours trying to clean it all up yourself, digging through shady data broker sites, filling out forms, sending emails, but why go through all that hassle? That's where Incogni comes in. They'll handle the entire process for you, tracking removal requests, verifying updates, and giving you peace of mind along the way. With their new custom removal feature, you can even point to any specific site you don't trust, and Incogni will wipe your data clean. It's fast, easy, and for Space Race viewers, you get an exclusive 60% off. Just use the link below and enter the code SPACERACE. Your information belongs to you, not some sketchy data goblin flipping your profile. Take control now. Here's another unusual flying object to add to the growing list of future spacecraft, but don't worry, this one won't be crashing into your backyard or setting off neighborhood alarms anytime soon. It's a sleek, oddly shaped re-entry vehicle recently unveiled by Radian Aerospace, a lesser-known but highly ambitious American company aiming to rewrite the rules of human spaceflight. This isn't just a prototype for fun or a cool demonstration. It's the early testbed for what they hope will become one of the most advanced and efficient spaceplanes ever created. The goal? To transport humans and cargo into orbit using a radically different approach, with no wasted materials and full reusability, potentially changing the economics of space travel forever. Now, what really sets this project apart from traditional rockets or even other spaceplanes is how Radian plans to get the spacecraft off the ground. Rather than launching vertically like SpaceX's Falcon 9 or NASA's SLS, Radian's vehicle will be propelled horizontally at high speed using a rocket sled mounted on a long track, essentially a railgun-style launch system. Think of a high-tech train with jet propulsion, shooting the spaceplane down a runway and into the sky. Once it reaches the required speed, the craft will fire its onboard engines to complete the trip into orbit. While this concept, often referred to as a rocket sled, dates back to the 1950s, it was never fully realized at the time. But now, for the first time in history, a private company is seriously pursuing this method as a potential path to orbit. To be clear, Radian isn't trying to build another Virgin Galactic-style joyride vehicle. While companies like Virgin are focused on suborbital flights for space tourism, giving passengers a brief moment of weightlessness before returning to Earth, Radian's ambitions go far beyond that. Their vehicle, known as Radian 1, is being designed to reach full orbit, which means it will have the capability to stay in space, dock with stations, and deliver both cargo and crew to various destinations. It's not a 5-minute thrill ride, it's a real spaceship meant for serious missions. And that makes all the difference. But there's more. One of the biggest challenges with any spacecraft is where, and how, it lands. Radian's engineers have thought this through carefully. Unlike traditional capsules that splash down in oceans or require specialized recovery teams, Radian 1 is built to land just like an airplane. In fact, any runway at least 10,000 feet long, such as those at many commercial airports, can serve as a landing site. That flexibility opens the door to faster turnaround times and reduced recovery costs. It makes the entire system much more practical for routine operations. In essence, Radian 1 is being designed to act like a commercial airliner, but one that happens to fly to space. However, getting to that point involves several major engineering challenges, particularly when it comes to re-entry. That's where the company's prototype test vehicle, the RV-3, comes into play. This small experimental spacecraft is being developed to test a critical piece of technology, the heat shield. When a vehicle comes back from space, it slams into Earth's atmosphere at speeds over 17,000 miles per hour. That creates intense heat, enough to melt metal if not properly protected. So Radian needs to make sure their spaceplane can survive this fiery plunge again and again without replacing parts every time. To accomplish that, they've developed a new thermal protection material called Durtherm, which they claim is a reusable, non-tile heat shield system. If you remember the space shuttle, you'll know it used thousands of fragile heat-resistant tiles that often cracked or broke. Durtherm is different. It's designed as a unified surface that doesn't degrade with each use, making it far more suitable for frequent flights. According to Livingston Holder, the company's chief technology officer, Durtherm allows high-speed flight of lightweight composite systems that can operate repeatedly without degradation, which is an absolute game-changer in the field of aerospace materials. Radiance 2026 test flight will see the RV-3 launched to simulate re-entry using this Durtherm heat shield. The goal isn't to go to orbit just yet. Instead, it's to validate the materials and systems under real-world conditions. The RV-3 will only have a couple of small thrusters, as the focus is entirely on surviving re-entry and collecting data. If it works as expected, it could prove that Radian's approach is not only viable but revolutionary. One of the most groundbreaking aspects of this entire project is that Radian is trying to create what's known as a single-stage-to-orbit vehicle, or SSTO. Unlike traditional launch systems, which involve multiple stages being discarded during ascent, an SSTO system uses one unified vehicle that goes all the way to orbit and returns intact. No boosters are jettisoned, no parts are left behind. The whole craft takes off, reaches space and comes back in one piece, ready to fly again. So far no one has ever pulled this off. But if Radian succeeds, it would represent a monumental leap forward in spaceflight efficiency and cost savings. Why is that such a big deal? Think about it like this. Every time a rocket launches with multiple stages, some components are thrown away, sometimes even into the ocean. Even with partial reusability like SpaceX's Falcon 9, there are limits. An SSTO system would change that paradigm entirely. Launching and recovering just one vehicle is far cheaper and simpler than recovering 2 or 3 separate pieces. If Radian nails this, they could slash launch costs dramatically and make space access more like airline travel. Fast, frequent, and cost-effective. As of now, the debut flight of Radian 1 is scheduled for 2028. That's just a few years away, and while delays in aerospace are common, even a slight shift would still make it a potentially historic moment. If Radian can hit its targets, they could become the first company to fly an SSTO spaceplane successfully, opening up entirely new possibilities for how we approach space exploration and transport. Now let's switch gears to another aerospace breakthrough, this one from across the world. If you've been closely following the SpaceX Starship program, then you're probably familiar with the massive stainless steel fuel tanks used in its super heavy booster. But here's something surprising. A recently revealed tank that looks almost exactly like those early Starship designs doesn't belong to SpaceX at all. In fact, it wasn't even built in the United States. It's a product of China, part of their ambitious new space program centered around a Starship-like rocket known as Long March 9. This massive rocket is being designed to take Chinese astronauts to the Moon and eventually to Mars, with a timeline aiming toward the mid-2030s. If successful, it would become the 12th addition to the Long March rocket family, but far and away the most powerful version ever built. In fact, Long March 9 is projected to generate over double the thrust of any previous Chinese rocket at liftoff. That's not just a step forward, it's a leap. With such power, the rocket would rival SpaceX's Starship in both payload capacity and liftoff thrust, making it the second most powerful launch system ever conceived, surpassing even NASA's Space Launch System, SLS, which is currently being developed for the Artemis moon missions. Interestingly, Long March 9 is not just a powerful rocket, it's also partially reusable. The first stage is expected to return and land either at the launch site or on a remote drone ship, echoing the successful techniques pioneered by SpaceX. The visual design and functionality of this new Chinese vehicle appear to have been heavily inspired by Starship, and that's no coincidence. Since 2016, China has been watching SpaceX closely, and as Starship continued to achieve milestones, China adjusted their designs accordingly. The original version of Long March 9 included solid rocket boosters and a 3-stage configuration. But over the years, that evolved into a cleaner, stainless steel design with emphasis on reusability. Now, China has reached a new milestone. They've completed construction of their first Pathfinder stainless steel tanks, a key component for testing and prototyping. One of the tanks measures 5 meters in diameter, a standard size by modern rocket standards. But the second tank is the real showstopper. It measures a staggering 10.6 meters across, which is even larger than SpaceX's Starship, which sits at 9 meters in diameter. That makes it the largest stainless steel rocket tank ever built in history, developed by the China Academy of Launch Vehicle Technology. For comparison, the legendary Saturn V rocket booster from the Apollo era had a diameter of about 10 meters, and it remains one of the most iconic and successful rockets ever launched. But China's new Long March 9 tank just edged past it. The only rocket that ever surpassed it in diameter was the Soviet Union's N-1 moon rocket, which had an enormous 17-meter diameter. However, the N-1 never reached space successfully. It exploded during all 4 of its test flights. That means, in terms of practical, successful launch vehicles, China's new tank has now entered historic territory. What makes this even more significant is that China plans to use the Long March 9 to carry astronauts to the Moon and Mars, potentially even before the United States completes its own Artemis missions. With a massive reusable rocket and ambitions that go far beyond low Earth orbit, China is clearly positioning itself as a serious contender in the next great space race. They're not just watching anymore, they're building.